Hello, Enterprise. Hi, everyone. My name is Ina Paricio, and I'm the Web Marketing Specialist here at Enterprise DB. I will be your host today for a webinar, New Enterprise Cloud Database Options for 2019. I am joined today by Jamie Watt, who's EDB's VP of Technical Support. Before we get started, I just want to go through a few housekeeping items. So first, this presentation is being recorded, so we will be sharing the recording along with the slides right after the broadcast. Second, the lines are muted. If you have any questions, please feel free to submit it in the question panel. Today's session is scheduled for 1 hour, and we expect the presentation to last approximately 45 minutes, and we will allot extra time for QA. If we do not have time to address all questions, we will follow up afterwards with any attendee whose questions was not answered. And now, without further ado, here is Jamie.
Good morning, afternoon, and evening, folks. As noted, I'm Jamie Watt, thankfully introduced by Ina. I am the VP of Technical Support here at EDB, overseeing several functions. Technical support is one of them specifically, as well as our cloud database service and our remote managed services, as well as some other functions. Today, we're going to be talking about the data and application strategies for those who are looking to migrate out of other databases, principally Oracle, and into Postgres. We'll also be looking at the private and public, and obviously hybrid as a result, cloud deployment models that can be used for the database. Subsequent to that, we'll be talking about the enterprise tools that we have available for managing your data and getting to your actual implementation. Thereafter, we'll be talking about the database workflow automation that's available today, such as containers, as well as what we see in the cloud space overall, depending upon your provider. And then we'll be doing a brief overview of EDB at large. So, jumping right in. The cloud is, of course, today's reality. In as much as we saw virtualization 10 plus years ago creeping into the bare metal infrastructure, today we see cloud firmly placing itself within the data center ecosystem. The economics are obvious. It certainly brings about a scale of cost that most physical implementations don't necessarily have available to them. It presents to you a sense of agility as you can scale up, scale down, scale laterally as needed. But it also needs to grow. There are many platforms out there. However, they share the same operational requirements. We all need availability. We all need security within that availability. And everything, of course, has to be performant because, frankly, if you don't have that above all else, then the compelling event of your product to your customer base and you as a consequence of EDB is not as important or monumentous as it could be. As you can see, the overall revenue associated to cloud growth year over year has changed significantly, and it's going to continue to scale as we see additional businesses grow into that space. So, where we look at the actual practical implications of customers who are trying to move their workloads into the cloud, whether it be a greenfield or new approach for them with Postgres or something that they're more seasoned with, we saw that 62% of our customers are actually doing new development within the cloud. That's obviously the most sacrosanct and insulated way to do such, given that you're not going to affect an existing implementation which may have an existing customer base and thus continuing requirements that have to be achieved rather than releasing something into the wild anew. However, we do see that 38% of the customers are migrating existing applications. Now, these may not always be mission critical at the initial phase, but we do see a growing number of mission critical applications that are actually moving into this space. Now, the migration can play itself out in several different fashions in terms of complexity. We see situations where there's really no change required at all. That's about 16% of what we've seen within the data. However, more than 50% requires very little change whatsoever. So, 20% or less of your application code really needs to be modified in order to get yourself into that space. Once we get beyond the 50%, you see that moderate is the next largest chunk. And of course, we get to the points where we see a substantial amount of code change required, extensive, and complete. Now, what brings about these code changes and what defines the best use cases? Well, from EDB's perspective, what we've seen, a good candidate is often dealing with things, dealing with their code in an ORM fashion. So where they're implementing their code, they're using Hibernate or Spring or something else that interfaces directly with JDBC, allowing the greatest agility for what it is they're doing with their code and what endpoints it's connecting to or drawing from. Certainly those that are dealing with procedures rather than your typical, let's say, Java stored procedure, functions, and packages that are written in PL SQL. As many of you are probably aware, PL SQL is certainly the most portable of the ways in which you can actually implement your code, because it's going to be most consistently achievable across various types of databases, and certainly within EDB Postgres. Now, having the ability to modify your source code is key. Having an application team that has some flexibility in understanding, maybe transitioning out of what could be a more inflexible or lower level driver interface model, such as, let's say, OCI, and into a JDBC layer, into a layer 4 model rather than a layer 2, allows you to have, again, more flexibility, more portability, and ultimately the best recommended method of getting to your data. And of course, having the availability of the application developers, having their perspective, having their insight, and having them being able to engage with those that are handling the overall migration strategy is key to actually achieving success. Not having a use for RAC, for scalability, for those that are in the Oracle space, is also a great candidate. RAC certainly has a high level of cost associated to it for its performance and availability. And finally, flashback. If there's not a need for flashback, or those means are being handled elsewhere within the overall design, then it's a good candidate, because again, flexibility is there, and you are less reliant on the license-specific technologies that are relative to the Oracle implementations. Now, where we see more difficulty, as I had mentioned a moment ago, moderate candidates come into situations such as an OCI interface, where an application is used to doing, let's say, a type 2 driver call. You tend to get in a potentially stickier situation, because ultimately that's interfacing with the database at its foundation via effectively an undocumented UPI. Spatial and XML, it depends on the usage and how the syntactical arguments are made. And finally, extensions such as .NET and ODBC are generally moderate candidates, because you need to understand whether or not you are drawing upon implementations which are specific to how Oracle will handle the arguments and the syntax, or it's something that is standardized. Now, where we run into the difficult candidates, Pro-C interfaces certainly present a challenge. EDB does actually bring a compelling capability for Pro-C compatibility. However, where you see application teams that may be writing in methods that aren't necessarily fully SQL standard adherent or ANSI adherent, you can run into some challenges when you're jumping over into a Postgres world. Transaction management control within PL SQL. Now, while we do have additional features that have been introduced into Postgres 11, managing the transactions within PL SQL is something that is significantly more reflective, or something that should be considered before it's brought into a Postgres environment, just to ensure that you aren't trying to do things such as, let's say, create database within the block transaction. Stored procedures which are written in Java are still a factor which is considered a candidate which could be difficult to ingest within Postgres. We do have stored procedures that have actually launched in version 11, most prominently within the EDB Postgres space, thanks to a lot of the work by the teams. And where we see teams that have a requirement or an application platform that requires RAC or requires flashback, as we had mentioned a few minutes ago, that's where you run into a little bit of a stickier situation, because you really have to start looking at the solution as a whole to understand whether or not you can separate yourself from that integration and put those requirements, such as complete high availability, into different pieces of the solution. We'll talk a little bit about containers at a later point in the webinar, as well as where we see other models, such as database as a service, play into this. Flashback, similarly, again, it relies somewhat upon how you implement this elsewhere in the solution and whether or not it's really a good candidate for a migration. And of course, other proprietary extensions do present challenges to us, because there may not be an analog that we have within Postgres to allow for that. However, oftentimes we see ways around that that actually allow the application developers to find themselves in a more portable situation rather than the anchored sense that they have where they're in Oracle today. So where we look at the overall hybrid and cloud deployment models today, particularly from EDB. EDB has recently launched the Cloud Database Service. Cloud Database Service allows you to spin up a cluster on demand within Amazon and soon to be elsewhere in a few minutes. It's highly flexible, as it allows for a pay-as-you-go on-demand modeling, and we are shortly looking to introduce the capability to have discounted longer-term cluster capabilities. And we bring with it the power of EDB Postgres's Oracle-compatible capabilities directly into the cloud. There is not another analog for this today within the Postgres space or elsewhere. So on the top level, what do we see within CDS? Database automation, allowing for simple provisioning, simple scaling, and full management of your clusters within the cloud. This does actually give you one Postgres, whether you're using Advanced Server or you're using the PostgreSQL builds, to actually run this across your infrastructure where you are using your database as a service and as a foundational element of your overall strategy. And it allows you to run that everywhere. Currently, we are available within 2 regions, both within US as well as Europe, and we are expanding in the future as well. We do have integration with our migration portal. The migration portal, for those of you who are not aware, allows a user or a DBA to test their schemas within this ingestion engine, and based off of its understandings of Oracle compatibility measures that may need to be taken to bring that over into Postgres, it can actually suggest or make modifications, and it learns. So where we find examples that we haven't run into before, there is a level of machine learning that allows it to bring that forward into future enhancements. The integration that we speak of is once that schema is available, you can spin up into CDS in mere minutes, and it allows you that ability right within the user experience. Now on CDS, we do offer predefined templates. So use cases that are covered for, let's say, your common developer, departmental needs such as finance versus legal versus operations versus your database administrators. Breed scale templates, which allow for additional replicas to be added to your cluster based off of the overall needs of transactions. And production use cases where you're going to see something that's more akin to, in AWS parlance, perhaps an M4X large. And of course, where we see the overall greatest opportunity within DBaaS is the resiliency, right? So you've got your clusters, which have obviously your master, your standbys, and your balanced transactions across that. But we are also monitoring the health of each of these nodes within the cluster and ensuring that there is availability. Now, this also allows you to produce clone events as well as failover events, depending upon what your needs are. You know, whether you may be taking a maintenance window or you have a failure event on your master, or it could be an issue, let's say, within the availability zone on Amazon, where you may need to transition the leadership to or promote one of your standbys to master state. Now, we can actually handle this within the capacity of the CDS service. Now, as I mentioned a moment ago, there is load balancing built into CDS, as well as automatic failover. But we also offer data encryption at rest, as well as an elastic scale out and scale up capability. So if your machine type is no longer sufficient for what you're looking to do with your implementation, we can get you to a healthier state quicker, whether it be relative to your IOPS needs or particular to, let's say, memory, storage, etc. Now on the back end, one of the things that is a significant differentiator for the CDS service is our support. So much like our support that we offer elsewhere within EDB Postgres' overall business, we have human-to-human support. Now there are capabilities for self-service, as well as a significant number of, and growing number, of knowledge base articles relative to the needs for a CDS user, as well as the documentation that is directly relative to, standing it up, implementation, day-to-day management. We also have the human-to-human support. So backing the EDB Postgres offering is our support team that has over 10 years of experience delivering Postgres needs to customers, regardless of whether they are in the cloud, on a container solution, or elsewhere. We also have people who are specific to CDS knowledge, who understand all the ins and outs of not just the database side of things, but also obviously the infra, which is serving up that solution. Now, all of these experts are actually certified within our own ecosystem of training, both on a level of professional certification and beyond. Now, these are real people. These are not bots that we are pointing our customers to. These are not basically prepackaged statements that really just get you to a canned reality. These are individuals who are 24/7, 365 there to help you with your needs. And because we want to ensure that we actually have the availability of the team in the mechanism which is most comfortable for all of our users, these team members are available via the support portal, via email, and actually via phone for those who are in our enterprise support mode, and Postgres Rocks. Postgres Rocks being our online user community that allows for user-to-user as well as EDB Postgres driven advice. So where you look at the overall cloud story with EDB Postgres, we have 4 different modes. Now, there are the self-managed databases, which amount to implementing EDB Postgres on EC2 compute. These are do-it-yourself. They're, of course, Oracle compatible, as they bring all the power of advanced server to a cloud environment. But they also allow you to have access to Postgres expertise, as they are supported by the overall technical support organizations across the globe. Now, where you want something that's more of a managed infrastructure, a DBaaS that is in a globalized multi-tenant solution, you would be looking towards the CDS solution. This is self-service provisioning. It's obviously a great use case for developers as well as short-term DBA needs. It allows for automatic failover and management of the solution, and of course 24/7 monitoring and actions as they are related to the overall service. We want to make sure that your data is available to you when you need it. Now, on the deep end of the pool, we've got the managed DBaaS solution. Now, for customers who have specific requirements about operating, let's say, a database as a service within their own infrastructure, within their own AWS infra, and soon to be other clouds, then we have an offering which allows us to deliver this same solution that we see within CDS to our customers in a privatized environment. This, of course, allows for live DBA assistance, as we've got not only the team that is backing you from a support perspective, but also our managed service team that allows for questions such as, let's say, optimization of a query or tuning of the overall performance of the cluster. But we also offer recommendations on design as well as architecture. Whether your needs may be relative to a specific cluster type or machine size, or how you want to manage your overall resiliency. All of that is rolled into Managed DBaaS. And then finally, for those who are in more of a roll your own mode for DBaaS, kind of the other end of the spectrum, as I mentioned, it's a do-it-yourself DBaaS. It allows for EDB Arc on AWS, gives you full control over your environment and how you manage your orchestration of your databases, and then finally allows for your own customized networking. So, within the AWS space, how you want to handle your VPCs, within a privatized cloud, how you want to handle your VIPs, EIPs in AWS parlance, or elsewhere. So the goal is to have a solution for everyone who is looking for an orchestration need of their databases that allows for full management and full resiliency with agility to respond to whatever the needs of the business may be. So what do we offer in terms of tool sets for data management and overall resiliency? We've talked a lot about DBaaS. We've talked a lot about the capabilities of CDS. But for those who are in either potentially an on-prem model or a colo model, or remain somewhat agnostic and may not yet be in the space of, let's say, either DBaaS or containers, a lot of folks may be looking to a more granularized solution that they can build into what they do today, whether it be in a virtualized environment, bare metal, whatever it might be. Our tools, which actually play across all of these, as well as containers and within the cloud, include Postgres Enterprise Manager. This allows you to, of course, monitor and manage your entire environment. It allows you to execute PL SQL right within the construct itself. It allows you to actually do, let's say, a dump, potentially a restore, run your SQL commands, and also check the overall health and trending of your databases. Allows you to implement either our standard set of probes within the agent on the server side, or it allows you to define your own as well. So if you have any specific needs that you want to be querying, you can make use of that absolutely within the scope of PEM. When you're doing it within an agent type model, obviously it gives you a lot more granularity, just as it would with another monitoring solution, to allow visibility into a lot of the CPU characteristics or perhaps network attributes. And then within let's say the agentless monitoring, you're looking more at database probes specifically, but you can look at the trending of these over time. You can certainly alert for, let's say, long-running queries, potentially locking events, all of these scenarios that your DBA is looking to have at the ready. Failover Manager allows for a database cluster resiliency without necessarily going into a full orchestration mode. So Failover Manager today interacts directly with the built-in Postgres replication model and allows for execution of fencing scripts to work with, let's say, load balancers like pgpool to ensure that when you have to incur a failover event between one node to another, that the connections go with it. And then backup and recovery for those who have more of a deep level need for having management of your database in terms of just having a recovery option. We make it simple with backup and recovery. Most of these tools integrate with one another, and we're continuing to bolster that day by day. So where we look at EDB compatibility with Oracle. Obviously, our goal is to get you to Postgres and get you all the way to the cloud where that's the objective. Now, AWS helps you get part of the way with schema and data only. We also handle that within the scope of the migration portal for your schema. However, EDB overall, within the overall offerings, allows you to get not just to schema and data, but the schema, the data, the code, and the interface. Where we've talked about migration via, let's say, the migration portal, as well as CDS, or our other services within the EDB portfolio, we can get you directly from the beginning all the way to a successful endpoint up and running at a performant level within the cloud on EDB Postgres. Now, how we do that from a nuts and bolts perspective, there are a whole lot of features within EDB Postgres that allow for advanced server, that allow for compatibility within the Oracle construct that lead back to what we talked about earlier, where you see a 51% case where there's very minimal change needed and 16% of no change whatsoever. So how do we do that? Well, we've of course got support for SQL extensions, decode, NVL, substrate, etc. But of course, PL SQL support as the native language. Ref cursors, arrays, V-arrays, and now pragmas, name parameters, all of these are considered to be within the scope of advanced server and to make it easy for our customers to bridge the gap. Tools where we see a parallel between EDB Plus and SQL Plus allow a simplified way for DBAs to make that leap, similarly with EDB Loader, without actually having to lose the familiarity that they have with SQL Plus or SQL Loader. Having a Oracle-like dictionary for all DBA and user views also makes it much more simpler for the DBA to make that transition. Now, in recent versions, we've actually announced wait state analysis, so that way you can have a better view of what is causing either locking events or delays to the overall performancy, and you can do that at a system in session level. Features-wise, we have supportability for packages, now stored procedures, functions, all the way down through dynamic SQL, materialized views, and partitioning. Data types, blobs, clobs, varchar2, and into drivers where we see JDBC and ODBC as the largest use cases, but we also offer some extensibility for OCI and Pro-C accessibility as well. As mentioned, those are a little bit more challenging, but where it's an absolute need within the business, we've made sure that we have an avenue to reach success. Now you'll see at the bottom, within Advanced Server 11, we have actually introduced the capability of Pragma Autonomous Transaction, which was a big request that we've seen from our Oracle users in the years past, given the consistent use of that within the DBA space, as well as DBMS Redact. Redaction capabilities allow for the ever-changing landscape that we see within both PCI and PII compliance, where applications may not perform the full encryption or masking without having some dependencies on the database to assist with that. Now, as I mentioned, we do have the migration portal that is fully integrated in several different key ways with the CDS service, but it also allows for users to do so independent of CDS. It is not a requisite. It is the first online portal for an Oracle to Postgres migration, and it allows for native Oracle compatibility. That includes your schemas, the code, and the application interfaces. So the only thing that we don't handle within the scope of this is really the data itself. Now, there's obviously a deep bench of knowledge from 10 years of migrations within the history of EDB, and we continue to augment that by crowdsourcing. As I mentioned earlier, we do have an implementation of machine learning for new code translations, so we can actually add and increase the success as well as the strength of this product for our users. So all of these are really components that lead to the current landscape of virtualization within the cloud as well as containers. So where do we see one use versus the other? Well, much as I mentioned, the evolution has been observed over the last 15 years in the space of virtualization. Similarly, we're seeing an arc between both virtualization and cloud, as well as virtualization, cloud, and container. Now, containers are certainly more DevOps-centric in the way that they are deployed, and you see, generally speaking, the database is a component of an application. It may not be the greatest foundation, and it may not be the largest player, but that's because it is more meant for a containerized space in that type of environment. Automated and scripted deployment, regardless of what your automation or orchestration platform happens to be. And really what drives people there, as I mentioned, is the flexibility and the ability to deliver a container through a number of orchestration models. Usually we see these start on private clouds, and usually we see these start with new applications. Now the reason for private cloud is, of course, it's kind of trying it out in your own sandbox before you become dependent on what may be platform level identities on specific providers. And then applications, as I mentioned earlier, where we see migrations in general, well, people moving into containers may not want to move something that is business critical, and they start to move things that may be more departmentally based, maybe more of a development space, maybe something that is less dependent on no disruption to the customer, and getting into a place where the business is more comfortable with a container design. Now, database as a service is definitely more IT-centric. It is much more akin to the model that we see today for our customers, where they are using, whether it be bare metal or they may be using virtualization. A lot of the customers out there are, of course, using VMware, maybe using OpenShift. The database is seen as a central resource to the overall architecture. Now, we see this as more of a self-serve for developers, as it allows for the easiest instantiation of a cluster or just a single node. So what are the primary drivers here? Generally, we see productivity and accessibility there. Because realistically, you can get up and running into a DBaaS service seamlessly. Typically, we do see these start on public clouds. The reason for that is, of course, a public cloud implementation already has the kinks and the wrinkles worked out, and it's just a matter of really getting yourself into the cloud provider on what is already an understood architecture at the database level. We do see new and existing applications that are moving in this space because, unlike containers, it's moving not necessarily for a like to a like, but a like to familiar environment as well as architecture. And it allows for a stable transition without having to learn significantly different paradigms from a technology perspective. Now for containers, we see the ability to develop, deploy, and scale applications simply. As any of you who are familiar with containers can attest to, the portability of them really is what drives the overall use of containers and pods. It is efficient because obviously you're eliminating the OS level overhead that you would see with your traditional implementation of, let's say, ESX or vSphere. Manageability-wise, it plugs directly into an orchestration platform and allows you to distribute applications and your entire infrastructure at scale, while realizing the benefits of what is effectively the next step beyond cloud virtualization. Now, EDB's containers implementation is built on Docker and is orchestrated with Kubernetes. So for data management and high availability, we have Advanced Server, as we have within our on-prem and we have within the cloud environment. And it's partnered with the failover manager container itself in a pod. This allows for the best resiliency between the containers and the overall need for the database availability. For read scalability, we also pull in PG pool containers. This allows for, of course, SQL routing, connection routing, as well as other finely tuned nuances that you may have to your session levels. From a database administration perspective, the PEM container, the Postgres Enterprise Manager container, allows you to bring the same values that we talked about earlier with PEM on the on-prem and in the cloud to the container space, monitoring, management, and tuning. And then within disaster recovery, of course, we've got backup and recovery accessible here, just as it is in the on-prem model, as well as elsewhere within the EDB portfolio. Our supported products are much what you see in a lot of the cloud providers and operating systems today. Kubernetes 1.6 and forward, Docker 12.1 and forward, OpenShift 3.6 and forward. And what we provide from our side is currently Advanced Server 10 and 9.6, EFM 3.0, PG Pool 3.5, BART 2.0, CentOS 6 and 7, and RHEL, of course, 6 and 7 accordingly. And because we're relying on Kubernetes, any cloud that actually has a true Kubernetes implementation or support for it is certainly accessible within our delivery. So we see AWS, of course, Azure, even though they have some changes coming to their container implementations at the end of 2019, GCP, and Alibaba. Our containers are certainly built to be lightweight. Straightforward deployment is really our key because we want folks to get up and running simply, but with stability. We want to make sure that you're able to scale and also drive it across different workloads, and of course plug into your standard orchestration models, as you can see here. So just a quick overview of EDB. It's no surprise that we see ourselves within the overall Magic Quadrant. We are actually the only open source based RDBMS that is in the Magic Quadrant in this year. With continuing advancements, we really only see that we continue to strengthen our position within the overall matrix here, and our customers certainly can attest to that with their testimony of success. So who do we see within that customer space? A lot of really big names. We serve SMB and LE equally in terms of how important we view each customer, but if you take a look at what we see within our customer base, we see a significant number of large enterprise major deployment environments, such as what you might see with, let's say, Kronos or MasterCard or Sony or Raytheon or any of the other names listed out here. Within the European space, of course, we have ABN AMRO, Ericsson, Vodafone, Telefonica, and Volvo. And within APAC, we see Hyundai, DBS, Samsung, Toyota, Alibaba, to name many others. We have over 4,000 customers, and we're enabling them to work smarter. We're obviously reducing the risk, and they're able to drive a greater sense of stability, accessibility, and scalability with EDB's help. Now, how we do this is in no small part due to our integration with the Postgres community. As you'll see here, we of course have two of the core team members, as no company is allotted more than two. We have two of the most prominent luminaries with Bruce Momjen, as well as Dave Page. Major contributors bring forward people like Andreas Freund. For those of you who are familiar with, let's say, the use cases and implementation over the years of logical replication, Andreas was certainly prominent in helping drive this into the Postgres community. Devram Gundes, Robert Haas, Thomas Monroe, and Amit Kapila. Now, within contributors, we certainly have a ever-growing list of people who are driving change into the community, whether it be within, let's say, the PG Pool projects, PG Admin, PG Bouncer, or the core database itself. We are continuing to make the largest difference to the Postgres community as well as the EDB Advanced Server customer base. One last thing we'd like to note before we jump into the Q&A is we do an event every year called Postgres Vision. This year it'll be hosted at the Boston Sheraton Hotel from June 24th to June 26th. And I highly encourage all of you to take a moment to consider attendance here, as we tend to see some really interesting conversations, as well as a lot of great customer interaction, as well as new ideas and corollaries, as well as challenges and successes being discussed between any number of scale of customers, going from, as I mentioned, the SMB space into the very large deployments that we may see, where you have databases ranging in the 50+ terabyte range, may have, let's say, 1,000+ schema. I will certainly be there, as will many others of the EDB staff, here to serve your needs, as well as see what we can do more for our customers as we go ahead. Thank you.
Great. Thank you so much, Jamie. So we have a few questions for you here before we conclude today's session. So I'm going to start with one right here. So first question is, what would be a good reason to pick DBaaS or database as a service over containers? How do I decide?
Well, I think it comes down to a couple of the points that I mentioned earlier. So if you're looking for something that could be done quickly without disrupting how your overall architecture team may operate today, DBaaS is the simplest change to make in many ways, because it doesn't require that your developers or the DevOps team really adopt containers just yet, and allows you kind of to bridge the old method of implementation and bring yourself into a newer state while readying yourself for containerization or however you may choose to implement in the future. Additionally, where we see DBaaS, as I mentioned, that brings with it management where desired, and that certainly takes away headache as well as overhead from our customers. Containerization, I would say, for those that are ready for and require a agnostic implementation that can be run across any environment, that's where we see probably the best use case of the growing number of people that are jumping into the container place today.
Great, thank you. Let's see. So, all right, so we also have a question right here. Let me just looking for it. All right. Okay, so do you offer any integration with AWS Outpost? Have you partnered with AWS in this space?
We have not as of yet, but we are looking at that excitedly towards the tail end of 2019, more from a potential perspective, given that Outpost brings a kind of a bilingual approach to implementation, where you're looking at a hybrid environment where people are able to view their infrastructure either as AWS or as it may be viewed within vSphere. It's certainly a compelling use case that is going to grow easily over time. And I think the offerings that we have that play specifically to an AWS infrastructure today, as well as the classic offerings and what we have growing in parallel for, let's say, containers, or just overall use within a OS-based environment, I think those partner well to bring us to a place where we may have stronger Outpost integration. And of course, where Outpost may bring additional VMware features down the road, such as, let's say, vVols or others, I think we will certainly have more capability potentially from a container side as well.
Perfect, great. So let's see, we have another question. Do you provide any master-master replication?
Okay, so I think the question here looks to be, do we provide any multi-master replication, or MMR, for those who are familiar with it? And we actually do. One thing we did not mention over the course of this webinar is replication server. So replication server has been around for a number of years. We actually have a successful publication subscription implementation today for the technology. We have a number of rather large customers that are using it in significant needs, whether it be localized or, let's say, metro pair designs. So that certainly does serve the needs of a number of customers for the MMR solution.
Gotcha. Okay. So here's another question. Is Failover Manager available for use on the cloud?
It is. I think right now, the one that is effectively most proven is Failover Manager, where you can't necessarily use VIPs as the transition method. It does allow for integration into effectively hook scripts that allow you to balance across EIPs. We are looking at other providers, but as of right now, that's the most explored space.
Great. So here's another question. Let's see. Okay, do you provide online or near zero downtime Oracle to EDB migration?
So we currently provide a capability to do so within the scope of a maintenance window, where we're looking at a need to do so with zero downtime or near zero downtime. We are actually looking at capability of integration between CDS and replication server capabilities in the year 2019. And for customers who are, or potential customers who are looking for that, I would certainly encourage them to reach out to us, as in advance of us providing that as a formalized offering, we may be able to do something for them as a design solution to get them to that space.
Great. Okay. Let's see. We have, well, we're getting many questions. So, okay. How does CDS, or Cloud Database Service, differ from other offerings out there today, like RDS?
Well, the biggest example is, of course, Oracle compatibility. That's just not there in RDS or any other platform peers that are out there today. But it also allows you to elect to either use Advanced Server for those who are using to serve their Oracle needs today, or for use of the community build. One thing to note about RDS is that it is highly integrated with and forked from the community, and it did so, I believe, most recently at 9.5. So there are some features that aren't there, significant features that have changed since 9.5 that make it a less palatable solution for people who are looking for a Postgres cloud option. So on CDS, as I mentioned, we of course have the human-to-human support. Those of you who may be more familiar with the Amazon support structure, even where you're adhering and paying a not insignificant number for the cost of your enterprise support within RDS and the AWS space, it is not driven and tailored to the Postgres need, whereas within CDS, we are fully AWS conversant, and we are also highly tailored to the needs for your database. And that's not just relative to break fix, it's also relative to recommendations and advice.
Perfect. All right, so let's see. We have another question right here. Okay. So which strategy do you find works best when presenting Cloud EDB as an option to current Oracle on-premise customers?
The best strategy that I've seen thus far is where you compare the potential cost implications as well as the anchoring. Because when a customer is looking at comparing, let's say, on-prem Oracle to CDS, generally they are looking at that as what is the cost factoring where I look at this versus Oracle Cloud. Oracle Cloud has continued to offer additional features, but has also increased cost factoring, and you are really kind of tied very deeply to it once you're in. A lot of the discussions that we've heard is that it's not so easy getting out once you're in, whereas with EDB Postgres and where we look at CDS, we allow for the greatest flexibility, not just in the migration, but in the management of your database solution, and allowing you flexibility to point to multiple driver types as well as existing in a heterogeneous environment.
Great. All right, so we have time for a couple more questions. One we got right here is, how works patch and upgrades on cloud? Do you do it without outage?
Currently, we do. There are two levels of that. One is done at the operating system level for the EC2 on the cluster, and of course the equivalent where we're looking at other cloud deployments in the very near future, as well as the database itself. Now, updates themselves, in other words, minor upgrades within a major version, are handled more seamlessly and don't necessarily require a significant window to be defined. Majors do require a restart of the master and would require some flexibility either in the scope of a true maintenance window, which is generally what we often recommend, or flexible timeout values and low traffic load, understanding that, of course, it takes time to bring a cluster back to full state after doing an upgrade. We are looking at potential down the road to allow for a seamless implementation of this as well.
Great. Okay. Here's another question. If EDB gets us most of the way and all of the way when we're going to the cloud, what's the difference?
Okay. I think that what we may be referring to here was there was a graphic that actually referred to this. So most of the way and all of the way really refers to kind of the overall stack of offerings that we have for the cloud. So most of the way may be seen as an example where you're doing roll your own, so to speak, where you're looking to implement, let's say, Arc in the cloud, and you're using either the migration portal or our migration toolkit to get as far as your schema, your code, and your initial data, but not necessarily up and running and implemented. Whereas with CDS, our goal is, and the managed DBaaS, our goal is to get you from end to end.
Great, great. All right, so I think we have time for one more question. Let's see. All right, so this was a question during the presentation. Can you expand more why no use of RAC for scalability? Enterprise DB cannot scale out as an Oracle RAC environment?
Enterprise DB does not necessarily have and nor do really anybody else without a significant amount of expense can really match what you're looking for in RAC by itself. We work within a overall solution where we've seen a number of customers who have successfully exited RAC by looking at the entirety of their design from an overall perspective. So understanding, what parts of what RAC does are played by EDB Postgres, as well as its relative tools that we've talked about in EFM, as well as CDS, where it may be relevant, use of PG pool for balancing, but also the infrastructure itself. So availability, where it's presented in the operating system level, where there may be clustering there. For example, within Red Hat, you may be using stretch clustering across sites. Within the cloud, using multiple availability zones as we do by default within CDS. It's where you're looking at RAC versus what we can implement to get a customer to a place where they have a highly available deployment. It's a matter of piecing together the right components to meet the need rather than having a direct analog within the database itself.
Great. Actually, we have just one more question for you, Jamie, before we go. So here, I've found that OCI migrations can be harder in my own experience, but they're worth the portability. Is there a reason I would not want to do this?
I would say the reason why one would necessarily not want to consider an OCI transition is if they have difficulty in getting out of the space where you have client-side libraries. So while pretty much everyone's recommendation at this point is to use a thin implementation and allow for Type 4 driver usage, there are some edge cases where someone's environment or someone's infrastructure may require OCI only as their usage. However, that's really a matter of finding when you reach that horizon in which you have to make that transition. So even in those cases, it's a matter of not if, but when.
Gotcha. All right, so I know we got plenty of questions today, so I apologize for those questions that we were unable to get to today, but that is all the time we have. Thank you all for joining. We will be sharing the recording along with the slides with you as soon as possible, so we'll get that. And then, I hope you have a great rest of your day. Thank you for joining.
Thanks, everyone.